Have you ever stopped to think about what makes one app feel lightning fast while another one just lags? It's not magic, it's something called the unseen engine of the digital world, data structures and algorithms. And today, we're going to pull back the curtain and see how these building blocks really shape our digital lives. Yeah, we've all been there, right? You tap an icon and one app is just instantly there, snappy and responsive. But another one, you're just stuck staring at that spinning wheel of death. You might blame your Wi-Fi, but you know what? A lot of the time, the real reason is hiding much deeper inside the code. That's right. It all comes down to the invisible architecture. The speed, the efficiency, pretty much everything about how a piece of software feels comes down to two things: how it organizes its data and the instructions it follows to use that data. It's a hidden world for sure, but it affects us every single day. So let's start right there. Section 1, the unseen engine. We're going to break down the components that power the apps you use constantly and see why they are the absolute key to understanding modern tech. All right, moving on to Section 2. The first piece of this engine is all about how you organize data. You can think of data structures as the blueprints for your information. I mean, you wouldn't build a house without a blueprint, right? Same idea. You need a plan for how all the pieces are going to fit together.
So what does that actually mean? Well, the key word here is efficiently. A data structure isn't just a box to dump information into. It's a smart, organized system designed to make finding and changing that data as fast and as memory-friendly as possible. That's the whole game.
And as you can see, programmers have a whole toolbox of these blueprints to choose from. A linked list, for example, is perfect for a music playlist where you really only care about what song comes next. A binary tree, that's great for organizing something like a file system, so you can find things fast. And for a social network, you absolutely need a graph to handle all those complex connections between people. The big takeaway is that each structure is built for a different kind of job. Okay, so if data structures are the blueprints, then what are algorithms? Well, sticking with the analogy, algorithms are the recipes. They're the step-by-step instructions that tell the computer exactly what to do with all that data you've so carefully organized. An algorithm has to be incredibly precise. It's not a suggestion. It's a complete, unambiguous set of rules. Whether you're sorting your contacts alphabetically or getting the fastest route on a map, trust me, there's an algorithm running behind the scenes, following its recipe to the letter. Here's a really simple example. Let's say you want to find the largest number in a list. A basic algorithm would be to just look at the first number, assume it's the largest, and then go through the rest of the list one by one. If you find a bigger number, you update your choice. It's simple, it works, but you can probably already see how this one-by-one approach could become a real problem if your list is huge. And this is where it all clicks into place: data structures and algorithms. They aren't two separate things you learn about. They are fundamentally connected. You can't have one without the other. They're a team. This quote just nails it. You can't just pick a random blueprint and a random recipe and hope for the best. The way you organize your data structure, directly influences the kind of algorithm you can use. And that combination, that is what determines how fast your app is going to be. Let's make this real. Imagine adding a new friend to your contacts list. If your contacts are in an array and that array is full, the app might have to do a ton of work. It has to create a whole new, bigger array and then copy every single one of your old contacts over. But with a linked list, it just links the new contact to the end. That's it. The end result is the same, new friend added, but the how is totally different, and so is the performance. And that difference between the array and the linked list points to a huge idea in software design: separating the what you want to do from the how you're going to do it. This powerful concept is called abstraction, which leads us to something called an abstract data type, or ADT. Think of an ADT like a contract. It tells you what you can do, the operations you can perform, but it completely hides how those operations are actually getting done behind the scenes. So what this means is that a programmer can use these really simple, intuitive commands like append or search without having to worry about all the nitty-gritty memory management stuff. This kind of abstraction is what lets developers build incredibly complex apps without getting lost in the weeds. Okay, enough theory. We've talked about blueprints and recipes, but what does this all really look like in the real world? Let's run a test and see just how dramatic the difference can be when you make the right choice. So here's our test, a really simple task. We just need to find out if one specific number exists inside a giant collection of other numbers. Simple yes or no. And when I say giant, I mean we're searching through 100,000 integers. Our algorithm's job is to sift through all of them and give us an answer. Okay, first up, we use a standard Python list, which works a lot like an array. To find our number, the algorithm has to go through one by one. And on this chart, that tall bar is our baseline time. It's not crazy slow, but in the software world, every millisecond counts. Now, what if we change the blueprint? What if, instead of that basic list, we use a data structure that was literally designed for super fast searching? Something like a hash table. And wow, just look at that difference. It's not just a little bit faster. It's not even in the same ballpark. With a set or a dictionary, which use a hash table under the hood, the search is practically instantaneous. Instead of checking every item, it basically knows exactly where to look. This, right here, is the power of picking the right tool for the job. And that's really the punchline to this whole thing. This isn't just some academic exercise. In the real world, this is the difference between an app that feels amazing and one that feels broken. So let's do a super quick recap. Data structures are your blueprints, algorithms are your instructions, their partnership is what decides performance, period, and abstract data types, ADTs, are the secret sauce that let us manage all this complexity by separating the what from the how. So the next time you search for something in your favorite app and get a result in the blink of an eye, you'll know it's no accident. It's that unseen engine, a perfectly chosen data structure and a clever algorithm working together. It's all around us, and now you know how it works.